Hey guys, in this video I'll be explaining you the stockSpan problem. I would encourage you to pause the video and read the problem statement. So what the problem statement says is that you are given the prices of a particular stock on each day. In this case, on day 1 it is 100, on day 2 it's 110, on day 3 it's 80, and so on. You need to find the span on each day, that is for day 1, day 2, day 3, and so on. Now what a span is. So span on any day I is defined as the maximum number of consecutive days just before the given day for which the price of the stock on the current day is less than its price on the given day. Let's figure it out via solving the span for each day in this example, because to me that statement was really confusing. So on day 1 the span is always 1 because nothing precedes day 1. On day 2, in this case 110 is more than 100, so the span is 110, which is more than 100, so the span is 1 plus 1, which is 2, because you count the day itself 2. So the day on day 3 the span is 1 again because 80 is less than 110. On day 4 the span is 2 because 95 is greater than 80, and you count the day 4 also, so it's 1 plus 1, which is 2. On day 5 the span is 3 because you count 80, 95, and 105. So 95 is less than 105, 80 is less than 105, and since 110 is more than 105, you won't count that. Okay. On day 6 the span is 6 here because 120 is greater than all the days which precede it, because 120 is more than 100, 110, 80, 95, and 105. So that's 5 days plus the day itself, which is 6. So how do we find out the span? So one easy way would be to compare the day on any ith day with all the days that precede it until you find a day that has a price greater than it. So for example, let's say you wanted to find the span of day 3. So you compare it with day 2. Since it's less, so the span is 1. For day 5, you compare it with day 4. Since it's less, you increment the span. Then you compare day 5 with day 3. It's less, you increment the span. Then you compare day 5 with day 2. It's more. Day 2 is more than day 5. So the price on day 2 is more than day 5. So you stop there and you do not increment the span. So, and you get the span as 3 for day 5. So this would take O(n) square. This would take O(n) square, because in the worst case possible, you would be comparing each day with all the days that precede it. Okay, so it's not that efficient of a solution. So I will explain you a solution which is much more efficient than this. So let's look into a much more efficient algorithm, and I call it jumping pointers. We'll solve it using jumping pointers. So what you do is, let's say you want to calculate the span on some given day I. So you take an index to point on that day. Okay, let's assume I'm calculating it for day 5, and you initialize an index j, which is I minus 1. This index is your jumping index. Okay, so you have your I as 5, j as I minus 1, which is 4, and you initialize your span of 5 as 1, because the span of 5 cannot be less than 1. So you initialize it as 1. So what you do is you compare the on price on ith day with price on jth day. If the price on jth day is more, then you do not do anything. You simply say the span on ith day is 1. Sorry, it's 1. But however, if the price on ith day is less, my bad, the price on ith day is more than price on jth day, what you do is you run a loop, you run a loop wherein you increment the span on ith day. I shouldn't use 5 since we are generalizing it here. Yeah, so you increment, this is I, okay? You increment the span on ith day by span of I is equal to span of I plus span of j, and you decrement the jumping pointer. Basically you jump the pointer from j to j minus span of j. Okay, so let's look what's happening now. So initially your span of I is 1. Now you compare 105 with 95. Since 105 is greater than 95, you increment the span of I, which is 1. So 1 is equal to 1 plus 1 is equals to 1 plus span of j. Span of j is 2. Span of 4 is 2. So you get 3. Okay, and you decrement your pointer, you jump your pointer to, so this is your span of 5 in first iteration, after first iteration, and your j becomes 4 minus span of j, which is 2. Your j jumps from 4 to 2. This is your new j. Okay, so again you compare. So you compare the price of j with price of I. Since now the price on ith day is less than jth day, because 105 is less than 110, of course, you stop. So now the resulting span is your span on ith day. As simple as that. Now let's take it for another day and check out whether it works. Okay. Now let's start I. Let's take for 6th day. So your j will be 5 because we initialize it as uh, I minus 1, and you initialize your span on day 6 as 1. So since 120 is greater than 105, so span on 6th day is equal to span on 6th day plus span on 5th day, which is equal to 1 plus 3, which is equal to 4, and j is equal to 5 minus span of 5th day, which is 3, which is equals to 2. So your span on 6th day, currently it's 4 after first iteration, and it's the jumping pointer has jumped from 5 to the 2nd day. Now you again compare 120 with 110 now. 110. So since you're comparing with 110, now what you do is, since 120 is still greater than 110, so you will increment your S6 by S6 plus S of J. S of J here is S of 2. So which is equal to 4 plus span of 2, 2nd day, which is equals to 2, which is equal to 6. Now your span of 6 is 6, and J goes from 2 minus span at 2nd day, which is 2, which is 0. So you stop because j cannot be less than 1. You stop when j reaches less than 1, or you find a day wherein price of ith day is lesser than price of jth day. So you eventually get your span as 6. So basically what you're doing is, instead of comparing with all the days that precede to day I, you basically compare with only specific days, because let's say you're comparing 6 with day 5. You don't need to compare with day 4 and day 3, because day 4 and day 3 have already contributed in the span of day 5. So by transitive property, it is known that I the price on day I will be greater than that of day J and all the stocks that contributed in the span of day J. Okay, so you straight away increment the span by the span of day J and you decrement the index J by the span of day J. Okay, so that's what it's happen. That's what is happening, and the time complexity of this algorithm is O of n, and worst case scenario it's 2n. This is your worst case scenario, and this is your time complexity. I'll leave it up to you to find out why this is the worst case scenario and why it's O of n. I'll leave that up to you. Okay, so that's it.